Here we're going to be looking at Maths Paper 1 2020 question 4, and it has to do with calculus. So you've got a cubic function here, f of x, and you've got a linear function, g of x. You are given something about the formula of f of x, and I presume you need to work out what k is. Yeah, you're told that given that f prime of 3 is equal to 12, or minus 12, show that k is equal to minus 9. Okay, well the first thing to do here is to work out what f prime of x is. Now f prime of x is the derivative of the function. So my function f of x is equal to x cubed plus k x squared plus 15x plus 8. So f prime of x, using our rule for differentiation, is 3x squared. You take the power, bring it to the front and drop the power down by 1, plus 2kx plus 15. So that is the derivative. That will allow me to work out the slope at any point on the curve. Now you're told that the f prime of 3, which is the slope where x is equal to 3, is equal to minus 12. So what we need to do here is substitute 3 in for x, which is 3 by 3 squared plus 2k times 3 plus 15. And that should be equal to minus 12 in the question. So 3 by 3 squared is 27. 27 plus 6k plus 15 equals minus 12. Bring them all over to one side. 6k is equal to minus 54. So therefore, k has to be minus 9, which is what they've asked us to do. Function g of x is a line that passes through two turning points of that function. Find the equation of g of x. So things we know to know for the equation of g of x. You need to know a point on it and you need to know its slope. Well, the slope can be worked out if we know 2 points on g of x. We know that it passes through the turning points, so we need to find the turning points of f of x. And the turning points on any function happen when the slope is equal to 0. That's the slope of the tangent. So if I know that f prime of x from the previous question was 3x squared minus 18x plus 15, the turning points happen when that slope is equal to 0. So I need to solve that resulting equation, divide everything by 3. So all I did was plug in the value of k there, which is minus 9, to get the minus 18. So dividing everything by 3, x squared minus 6x plus 5 equals to 0. So our factors here, minus 5 and 1. So x equals 5, or x equals to 1. So the corresponding y values are found by plugging it back into the original equation. We get 5 cubed minus 9 times 5 squared plus 15 times 5 plus 8. Putting that into the calculator, we get a result of minus 17. And f of 1 is 1 cubed minus 9 times 1 squared plus 15 times 1 plus 8. And here we get a result of 15. Okay, so there are 2 points. It's the point 5 minus 17 and the point 1, 15. They are both on g of x, so therefore the slope is going to be 15 minus 17 over 1 minus 5, which is equal to 32. So our equation then, well, the equation of any line is y minus y1 equals m times x minus x1. So we can just use any value we want from the function. We may as well just stick with that one. And we've got our slope, so we're just going to substitute that in there for those values, and we end up with y minus y1, which is 15, is equal to minus 8 times x minus 1. And when we plug that in, y minus 15 is equal to minus 8x plus 8. Bring those over, and the equation becomes 8x plus y minus 23 is equal to 0. So that's the function g of x. Now the next part, show that the graph g of x contains the point of inflection. So if you have a cubic equation like this, so I know this is a positive slope. Okay, right here, I know when I turn this around, the slope is getting less and less positive. Here the slope is equal to 0. The slope of the tangent being 0 always happens at the maximum or minimum. Then suddenly the slope gets more negative. And as the slope gets more negative, there's a point here at which the graph actually has to become, it's getting more and more negative here, but it actually has to start getting less and less negative to go into its second turning point here. And that point there, where it changes direction essentially, is our inflection point. And we find that out by working out the second derivative of the function. So f double prime of x, which is just deriving the derivative. So if the derivative was 3x squared minus 18x plus 15, then the derivative of that will be 6x minus 18. Okay, and the inflection point happens when that is equal to 0. So 6x equals 18, x is equal to 3. What's the corresponding value of y? Well, plug 3 into the original cubic. It's going to be 3 cubed minus 9 times 3 squared plus 15 times 3 plus 8. You put that into your calculator and you get a result of minus 1. So the inflection point is 3 minus 1. Now, we're asked to show that the graph of g of x contains that point. Well, we just need to plug that into the equation of the line. We need to plug this into the equation of the line and show that it is equal to 0. So it's going to be 8 times 3 plus minus 1. So that's going to be 24 minus 1, which is 23, minus 23. That does equal to 0. So g of x does contain the inflection point of f of x. So 3 minus 1 is on g of x.